Welcome back on ModsTime. Let's see a video first of the Qualcast Commodore mowing, shall we? We'll test the mower in this overgrown lawn. I haven't mowed it for a week. It's pretty nasty. Let's see how it's gonna do it. Okay, finished mowing. I didn't do the edges, but if you can see, the grass was a bit overgrown and did a bit of a scarping in spots. Well, put it this way, I reckon a petrol motor would have choked there. This one, no sweat. Probably 80 to 90 squares, something like that. So that's how much I got in the bin, and I have a bit left in the grass catcher as well. Alrighty. Was a big learning curve passing on from petrol engines to DC motors, that's for sure. I have owned for a couple of months previously a petrol real mower, cylinder mower, and I do remember from difference when you change propulsion every time, the petrol mower was a little bit losing RPMs, and then was coming back to its setup, so the RPMs was coming back obviously. So this, let's call this one as a bit of a soft start, so it was not much impact on the gearing here. So going back to DC motors basically they are fully on at the same level output every time. So basically when this happens, there is a bit of a forces they're pushing on the sprockets, chains, and so on. So prototype number 2, successful achieved to replace a petrol motor with a DC one. So literally, besides the electrical adaptation which came from Mozito, I just copied that, so I made that one working. I only had a bit of a bad luck with the electrical clutch, which is right here. This one basically has got a fan in there as well, does the same functions, about the same characteristics as the previous one. Talking about cost wise, maybe I don't know, up to a $10 difference only in between two, but definitely I'm not buying this one again. Going back to my DC motor, I have used the online formula to convert, which is 1 horsepower equals 0.75 kilowatts. In the meantime, I got a reply. I thought to double check my motor supply, DC motor supply as well. He gave me a bit of a confusing answer, which is completely different. So in the meantime, I asked him to double check with the his supplier. We're waiting for news, might take a while. So this engine's horsepowers were 1 petrol. The old petrol engine from this mower was 1 horsepower rated. So I got mine, this one again, which is not 750. This is actually 1 kilowatt. I just went a little bit over, just a bit of an extra power there. So 48 volts motor, and from that point forward, once I choose my motor, I went back and choose a battery, 48 volts battery as well, and the clutch or the speed regulator is about the same, 48 volts maximum working voltage. Okay, now that we talked about the electrical setup, going back to mechanical adaptation. So on this little one, I end up using the same solid coupling, which I don't really quite recommend. A solid one would be better to use the previous one coupling with the rubber in between, because that's gonna give you a bit of a coverage there. So otherwise you have to have perfectly raised and leveled the motor with the axe, with the shaft there, so there is no extra forces, which in the long run is gonna damage your bearings basically. Yeah, so for now I went with this as it is, made a bit of a platform improvised there, lifted the motor up, and this is the sprockets chain setup. So basically right now I only replaced a petrol mower with a DC one. I still can't backlap it. I should not backlap this one, because the chain tensioner right there, that's, yeah, if you want to be able to backlap it, I'm still running this one as a mower with a petrol engine on, so I'm still only going forwards and so on. I'm not backlapping it. I had to backlap it separately. I need to make there a sprocket actually
belt tensioner, so you need something to spin. Once you get that in place, then you'll be able to use that, actually the same setup, to back up your reels. This is not my goal, so I'm not gonna waste my energy here and finances on that, because my goal is different one, which will start up with the next stage of this project. Mow at your mower's best, but at your own pace. I'll add some more details in the description. So on this setup, basically I was running only at 70% of the motor's capacity, just taking in consideration that I took a 25% extra stronger DC motor for this lawnmower itself. I still can't measure the forces here. When everything is running, it's fine, but there is a bit of a hammer in the chains when we stop. Once you finish mowing, you turn around and then you release the clutch again, so to engage the propulsion, that there is a bit of a hammer. So I'm not sure, I can't measure those forces. What are they and how quickly chains or sprockets are gonna get damaged in this situation. As I said, I'm not gonna spend any more time on this, because this is not my final destination. My final destination, mow at your mower's best, but at your own pace, involves running the reel on a separate DC mower, because that one's gonna go non-stop on high revs, high RPMs, and then have a second motor, a gear DC motor, which is gonna be traveling at lower RPMs and higher torque, and that should give us a smooth, soft change in between braking and getting back in movement. So, still having lots of unanswered questions on the table. I couldn't count on any of this information, I just spoke about it. So how I have calibrated my machine, I reversed calibrated it. Let me explain. As I said, I owned for a couple of good months a Petrol cylinder mower before, and I remember its walking speed was a little bit fast walking. So what I've done, I took this mower, I put it here on this concrete path, and I started slow, like 20%, 30%, until I got to a comfortable working speed for me, which was about 70%. And that's how and why I'm running it only at 70% on the lawn. That was the most comfortable feel in propulsion, starting up, slowing down, and running the reel. Torque-wise, power-wise of mowing, I can say, as I did, I think, added a video before, I've done a bit of a scalping here. Mowing this lawn is a little bit I ignored, and this mower didn't even smile, didn't even slow down the RPMs, just went fully on all the time, because that's what DC motors do. So when that one is under load, the motor, I don't need to increase the RPMs. The electrical clutch does that automatically. That one releases more voltage to the motor, trying to maintain the same setup of 70% run of the motor. I will be trying this for a couple of months. Not gonna rush with this next stage. I'll just take it a little bit easy. Before I go ahead, I want to make sure this is all good and perfect running. So it's only time can test that. One more thing about the electrical circuit. So once I've done my setup, I had mowed about 150 squares, and all the way up to that end, the first mows, when I use this machine, I actually always checked how warm my circuit, if it got any warm or not. And yeah, I can say it was cold as. I checked the electrical clutch there, or the DC motor regulator. I checked all my joints, electrical cable joints as well. All sweet. Talking about the motor itself, obviously any motor, electrical motor being under load, is gonna warm up. Yes. So these DC motors, they are not industrial types. They are basically buggy types. for golf carts and electrical scooters and so on. So they are designed on taking into consideration that they don't run always at high speeds. You have always acceleration, deceleration, which gives them a chance to cool down. In this case, mowing your lawns, basically, they are always constant under load. So if you run them at maximum, I haven't run mine at 100% all the times yet. I might do it later on. I just want to now to slowly test it at 70%, see how it goes. But it was not that hot. It was just warm. I was able to hold my hand on it. It was just nice and warm for 150 square meters. I'm pretty happy about that. So as a resume towards choosing your own DC motor, probably I would go a little bit higher and in strength, and then not run it at 100%. So take a bit more than you need and run it less than that, basically. So in this way, your motor is not gonna overheat. So this mower, the Qualcast Commodore, is a 14-inch one, and no worries. This motor did a really brilliant job with the mower from my experience. I can share. Next, a little bit, let's say a special project on stage 1 of this project will be, even now I have my e-bike battery, next one will be to make it possible to run this mower on a 2 18 volts batteries bank. I'm waiting for some parts, so whenever they come, we'll try and make a bit of a video there. Just because everyone home has got power tools and we'll have 18 volts batteries plenty. I have at least probably 5 in there, so that would be a good point to save a bit of a cost on your project. Like not buying a battery, you just buy only the 3D printed slots batteries, and yeah, you'll be able to use your own batteries from home. Only 36 volts though, so you might be limited there by the size of your machine, what batteries you can use, unless you're happy to go through a lot of pairs of batteries during your mow. It's, I guess, a bit of a formula there, how big your lawn is, how big your machine is, and what's better for you works wise. Either you want to get the slots, use your own 18 volts from home, or just buy a e-bike battery as I did with this one. If possibly I missed anything, please feel free to comment, and I'll make a list of the comments, and we'll come back with another video covering for them. Till then, I will wait to hear from you guys and girls, and I'll say see you in the next video on ModsTime.